So here I'm going to talk about standard deviation and variance. What is the meaning, what is the interpretation, and how it is useful for almost all the calculations under statistics. So before going into Minitab, let me explain manual way of understanding the standard deviation. Let's say I'm just going in my kindergarten class and I take only 5 students for easy number crunching. And the age of 5 students, one is, let's say, 6 years old, one is 7 years old, one is 8 years old, one is 5 years old, one is 4 year old. So I have these 5 students and their ages. If I take the sum of all, this is going to be 6 plus 7, 13, plus 8, 21, plus 5, 26, and this is going to be 30. If I take the average of this, average is divided by 5, which is going to be 6. Now let's look into this. If I divide the 6 minus 6, 7 minus 6, 8 minus 6, 5 minus 6, 4 minus 6, what do I get? Here I get 0, here I get 1, here I get 2, here I get minus 1, here I get minus 2. And if I sum all of them from 1 to 5, I equal to 1 to 5, what I get? I get minus 2, minus 1, minus 3, plus 3, that becomes 0. That is not, and the story is over here. We can't perform, we can't conclude anything. There is one thing which is either we can take the absolute values of these numbers or we can take the square of these numbers. So let's do the absolute value. Absolute values are written in this form, which is x bar or xi minus x bar that we did. So 0 absolute value is 0, 1 absolute value is 1, 2 absolute value is 2, minus 1 absolute value is plus 1, minus 2 absolute value is 2. What is the value that we get? 6. This is one thing. We will talk about this later. Now the second thing is to do xi minus x bar and this make this square. Square means, so 0 square is 0, 1 square is 1, 2 square 2 multiplied by 2 4, 1 square is 1, 2 square is 4. I mean, sorry, I have to perform with this. So 1 square is 1, 2 square is 2, 4, minus 1 into minus 1 is plus 1, minus 2 multiplied with minus 2 becomes 4. What is the value we are getting here? 10. So this is 10. The formula of sigma square is equal to xi minus x bar square sum of all divided by capital N. Capital N is sample or this 5 number. So this value, upper value, we got already 10 divided by 5 because number of observations we have 5. What we are getting? 2. So this is sigma square. Sigma square is called variance, and when you do just sigma, so I remove this and then I just put here square root of 2. This is called standard deviation. So this is the relationship, means variance equal to standard deviation square. So if in question variance is given, you can do a standard deviation. If a standard deviation is given, variance you can calculate. So this is for population. Capital N represents for population. Now again, I just do little bit more. So this sigma square is for population. For sample, it is denoted by a small a s, and the formula will be same, except in denominator, what comes n minus 1, means this 5 minus 1. So I will do this 10 divided by 5 minus 1. You can refer on the slide number 35, I believe. 5, which is 4. So what is the s that is for sample is 2.5. Oh, sorry, this is s square. Basically, this is sample variance, and small as is square root of 2.5. Now, this is a calculation we have just done. We understand what is the difference between variance and standard deviation. Now, let's look into the interpretation of uh, this concept. So I'm just making a clear thing, erase. So let me just erase some of the items. Now look into this. Suppose, this is age of the students. Suppose everyone is 6 years old. In my class, all 5 students, those are there, they are all 6 years old. This would be 30. The average would be 36. And when I do subtract with 6, everything will be 0. Sorry, everything will be 0. Now if I do absolute value or square, doesn't matter, because we can't do any operation after this, because 0 means 0. That means here, sigma would be 0. Variance would be, sigma square would be also 0. What do we indicate? What do we understand from this? This means, what is the ideal if you want a consistent data, if you want, no variability in a data, ideal situation, everything will be same. So higher is the variability in the data, higher is the standard deviation. And no variability in the data means 0 is the standard deviation. Practically, that is not possible. Practically, 0 standard deviation or 0 variance is not possible. But what is the ideal value? Ideal value is close to 0. So smaller the value of variance or standard deviation, that means you have consistency in the data. Otherwise, higher the value of standard deviation and variance means inconsistency. So what is our aim? Always have a data which has low variability. Now look into the simple example of runway that we do, where we have on runway of the any airport. This is the line. This is a standard line. Every time any plane take off or land, they follow this line. Means front landing gear is right on this line. Okay, this is a standard. or this is deviation. And then let's say, so this is ideal situation. Most of the time they follow this. Another thing is that this is a situation, first plane which takes off or land, follow this line. Second plane, follow this line, you know, means front landing. And third is this. This is our ideal. So I'm just keeping this ideal. See, deviation from the standard line. This is smaller. This is second is smaller. So this, the one plane which is landing right on this standard line will have no risk of derailing or no risk of going out of the runway. A has less risk as compared to B. B has less risk as compared to C, and but B has more risk as compared to B. So you can understand the deviation from standard line. That means sigma also indicates the risk associated. Higher the value of sigma means higher the risk associated, or higher the inconsistency there. Therefore, aviation industry follows the Six Sigma. Six Sigma, this is another concept we will learn in coming modules. Six Sigma means this is sigma and this is Six Sigma. That means six is number, sigma is symbol. 99.73% consistency. So we'll talk about this in coming. So this is means Six Sigma is also an indicator of quality, that only 3.4 defects are permitted out of million sample. So if there are million samples, only 3.4 can be defective. Similarly, if there are 1 million flights that take off and land, there is only 3 or 4 flights they can go out of the runway, or they can skid from the runway. Otherwise, aviation industry is following Six Sigma. So keep in mind, sigma should be zero. Ideally, practically, this is not possible. So what is our approach is always, if you want to see consistency of data, this should be close to zero. And variance and sigma relationship. How do we do now? It's a matter of doing. So I'm just going to show you how do we do on Minitab. And so this is right here. Go under statistics, basic statistics. Under basic statistics, go this and let me do fare in pound. So let me do none, and where is the variance? And this is variance, and this is a standard deviation. This is, let me see the mean. So mean is this, standard deviation is this, and variance is this. This is high. And there you can see the fare in pound is highly, it is not consistent. Somebody is paying $500 a pound, somebody is paying no. So this is here. Another way to see the standard deviation, I go under graph, and I go under histogram, and under this I can go and see the. So basically this also represent, the inconsistency. The mean is 32.46, standard deviation is this. So everything is right here under navigation.